Medical diagnosis in artificial intelligence, term paper. Author is Bill, a student from Makerere University, Uganda. The contents of this presentation term paper are: there is an introduction, there's a background, motivation, the literature review, the methodology, results and discussion, conclusions and future works, the dataset used, the Python source code, acknowledgement, and the references. So in our introduction, we talk about misdiagnosis. It's a big problem that can lead to death of victims, and about 28% of cancer cases are misdiagnosed, and the longer it takes to diagnose a cancer, the less survival chances. At times, patients are misdiagnosed. A serious example is Ted Blackwell. This victim was misdiagnosed by doctors from a Kaiser clinic in California with headache, yet it was cerebral bleeding he was actually suffering from. This is so dangerous. It can cause loss of lives. Imagine such a big blunder. It can be so fatal. So, what are the background and motivation of our project? First of all, we will talk about machine learning, which was ideated first in 1943 by a logician, Walter Pitts, and neuroscientist Warren M.C. Coolidge, who published a mathematical paper mapping the decision-making process in human cognition and neural network. And in 1992, Arthur Samuel at IBM wrote the first computer program that played a game of checkers. Our literature review, here we are going to talk about maybe past cases of people who have done this, people who have maybe made a model that can diagnose a disease. And an example here is Pradhan et al., who evaluated several machine learning algorithms which are flexible for lung cancer recognition correlated with the Internet of Things. And he did a lot more. What are the gaps in the literature? Here we are going to talk about maybe the things that are stopping us from achieving our maximum goal, from having a higher precision score or having a better model. Here, automated machine learning without a human in the loop, especially in the medical field, has a risk to model artifacts because medical data often contains uncertainty, noise, missing data, and the cause of missing data can be data corruption or failure of using the data. Noise. Here, we are talking about our summary of the term paper contributions means how we are. Here we are going to be tackling how we are going to tackle these problems like noise, how we shall tackle the problem of missing data. This is where the summary of the term paper contributions comes in. Noise, we can handle this by using binning. In this technique, sorted data is placed into bins or buckets. Yes, and smoothing can be by bin mean, bin median, or bin boundaries. Outliers can be smoothed by using binning and then smoothing it. The detected outliers may be smoothed or removed. Missing data can be handled in various ways. For example, deleting rows with missing values, imputing missing values for continuous variables, and many more others. And what's the methodology used? This refers to the method used to develop our model. Here, we have the fuzzy inference diagnosis of prostate cancer. This can be used. Then there's the K-means, the K neural networks. There are different methodologies that can be used, and this shows steps or procedures of how this fuzzy inference diagnosis can be done. The dataset description, This one is where we describe the data set we have used. It has enough data. It reaches consensus among data labels. The data is secure and discrete, and these are characteristics required for a data set to be good. The data set contains the signs and symptoms of prostate cancer. It also contains examples of patients suffering from the cancer. It contains signs and symptoms. And then here we have the data preparation and exploratory data analysis. This is a technique. The ADA is a technique used to understand various aspects of the data. You delete rows which have missing values more than 2, and also columns with more than 2 missing values. That's what you do in order to make your data better. The objectives, one of the objectives is it helps understand the faults in the data, and it also helps determine similarities, remove redundancies. Here now we have the artificial intelligence model selection and optimization. Model selection is the process of selecting one final machine learning model from among a collection of candidate machine learning models for training datasets. Accountability. This means looking for solid evidence of governance at the organization level, including clear goals and objectives for the AI system. The results and discussion. Here, we will use the confusion matrix. It's a table that is used in classification problems to assess where errors in the model are made. And then we have the conclusion and future works. Artificial intelligence methods automate the process and make them available more widely. However, it is not being used to its full potential in the medical field. It can be applied fully in the medical domain once all aspects, including uncertainty, quantification, are considered. With the help of AI, early diagnosis of disease becomes a reality and also saves time and money. This is indeed a good project that really requires more energy to be put across. It could solve and bring a lot better results for us all as far as health is concerned. Dataset and Python source code used. These are the links you can click and you can have a go at it. I acknowledge Makerere University through providing research materials, and then see bioportal for cancer genomics. That's why I got my data set. And then I have a few references. Well, there are a lot more in my LaTeX PDF and a lot more explanations there.